Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No, we've got a mixture here. Now, Amy is going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey everybody, welcome to Wednesday night math night. Like Dr. A said, I am Amy Sink and I am one of the math specialists here at the Learning Liaisons. And we just love what we get to do here, which is help you pass that certification exam and help you build that confidence and competence with your math skills so that you can pass that certification exam. So welcome to Wednesday night math night. We are here every week. We go through a large span of problems, pre-K through 12th grade. And so if there's something specific that you want to see me go over, do not hesitate to let me know in the comment box. Find me on social media. Tag me in any of our Facebook groups and let me know what do you want to see me go over in the upcoming weeks, because that helps me serve you better. That helps me build problems that are going to help you be more successful. And that's really why we're here. So don't hesitate to let me know in the comment box. In the comment box, let me know where you're from. What test are you prepping for? And I always like to do a get to know you question so it feels a little less like a computer screen. Where are you from? What test are you prepping for? And for your birthday, I don't know why this question came in my head because it's not my birthday anytime soon, but for your birthday, are you like an ice cream person, a cake person, a cookie person, cookie cake? Like what do you like for like a good birthday dessert? Donuts is like a super popular one now. I love a good cookie cake. Now I have a gluten allergy, so it's kind of hard to find a good gluten-free cookie cake, but I am a cookie cake girl through and through. I also love a good ice cream cake. Cake is like, that would be my like last choice, cake or cookies, but a cookie cake or a ice cream cake, love that. So I always do a next week section. Unfortunately, my comments are not working right now. I will be able to see them when this is complete, but I cannot see the comments right now, live time. But please don't hesitate to let me know what you need help with or what questions you have, and I will make sure to address them. So this is going to be my next week section. I always like to create a next week section, and I will list out the things that you want to see me go over in the upcoming weeks. Because like I said, that helps me help you. So without further ado, let's go ahead and start with problem number 1. A computer applications teacher asks the class to write a program to create a list of computer codes for labeling the computers at the school. Each code must begin with an uppercase capital letter from the 26-letter English alphabet, followed by 5 digits. The digits may be repeated, but the code cannot end in 0 or 1. How many codes can be created? So when we're looking at something like this, where we're looking for the number of combinations of something that can happen, we're really just thinking about multiplication. But how we apply that multiplication is what matters in this situation. So we know that we are looking for an uppercase letter to start. So my first piece of my code is going to be an uppercase letter, and it has to be an uppercase letter from the 26-letter alphabet. So how many different options can sit in that spot? There are 26 different options that can sit in that spot. I could put a capital A, capital B, capital C, capital D, capital E, F, G, H, I, J, K, L, M, N, O, P, all the way to Z. Then I have, it says it is followed by 5 digits. So I have 1, 2, 3, 4, 5 digits that follow that capital letter that's sitting there. And the digits may be repeated. And this is a critical statement in this problem, because if they could not be repeated, then we would have fewer and fewer and fewer and fewer digits as an option as we move down the line. But literally the code could be A222222, right? Because the digits are allowed to be repeated. It doesn't say that they can't ever be repeated. So how many digits are there? A digit is a singular number that sits in a place value. Well, you have 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 is not a digit because it has 2 spots being taken up, but 0 is a digit. So we still have 10 options. So I have 10 options for this spot, 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 10 options for this spot. But then there's a little tiny piece of information that we haven't addressed yet. It says the code, the code cannot end in a 0 or a 1. So this spot right here has some additional criteria that we have to follow. So instead of 10 options, we now have only 8 options, because it can't be a 0 or a 1, but it could be a 2, 3, 4, 5, 6, 7, 8, or 9. So that leaves us 8 digits that can sit there. And then the way that we figure out the combination, or how many there are, is we literally just multiply all of these values together, and it'll give us the number of combinations that we have. So I'm going to get my handy dandy calculator. 26 times 10 times 10 times 10 times 10 times 8. So 4 10s, an 8, and a 26. And that equals 2,080,000. 2,080,000 options. So C is the correct answer. Now, What if they said the digits may not be repeated and the code cannot end in a 0 or 1? Well, then in that case, we would have 10 options here, 9 options here, 8 options here, 7 options here, and we would scale it down to 6. So instead of 10, 10, 10, 10, 10, does that make sense? We would end up scaling it down because once I use a digit, I can't use it again. And then once I use that digit, I can't use it again. So we would have fewer and fewer digit options as we move down the line. So that's how you would change it if we were scaling it down because the digits could not be repeated, but that wasn't one of the criteria. And so in this case, 2,080,000 would be the correct answer. All right, let's move on to problem number 2. Gerald works at a local bakery. The bakery can make 342 cookies in 21 minutes. At this rate, how many cookies can they make in 5 hours? At this rate, how many cookies can they make in 5 hours? So when we look at this problem, there's 2 different ways that we can solve it. We can solve it using a unit rate, or we can solve it using a proportion. Either way is going to get us the correct answer. It's just a matter of which way your brain thinks. So if we're going to do it using a unit rate, the bakery can make 342 cookies in 21 minutes. So how many cookies can they make in 1 minute? How many cookies can they make in 1 minute? Well, in order to figure that out, I would need to divide 342 by 21. Because if I do 342 divided by 21, I'm taking the 21 minutes that I have and I'm distributing those cookies or dividing those cookies into each minute. And then I can figure out how many cookies I have per minute. So if I do 342 divided by 21, I get 16.285 cookies in 1 minute. And then I can take that information and just scale it to 5 hours. So then how many cookies could I make in 5 hours? Well, I'm not going to do 5 hours. I'm not going to do 16.285 times 5 because that would be how many cookies I could make in 5 minutes. But what I am going to do is I'm going to convert that 5 hours into minutes. So 5 hours equals how many minutes? Well, we know that 1 hour equals 60 minutes. And so if I'm going in this direction on my conversion chart, I need to do 1 times 60 to get 60. So I need to do 5 times 60, which is 300 minutes. So how many cookies can they make in 300 minutes? Well, if they can make 16.285 cookies in 1 minute, then I can just multiply the 300 times that 16.285 to figure out how many cookies they can make in 300 minutes. So 300 times 16.285 equals 4,885.5 cookies. And it does not look like the correct answer is sitting there. And I'm going to show you why. And maybe I wrote this problem, so maybe this is just a terribly written problem. Let's go ahead and do it with the proportion, and I'll show you what happened. So now, instead of that, let's do it using a proportion. So 342 cookies in 21 minutes equals X amount of cookies in 300 minutes. So I'm going to multiply 342 times 300. And that's going to equal 21x, because this is really what we're looking for, right? And 342 times 300 is 102,600 equals 21x. And if I divide both sides by 21, okay, it wasn't a bad problem. I just forgot to change the answer choices. I like when that happens. X equals the same thing, 4,885.5 cookies. So I wrote this problem from another problem. And I like adjusted some of the language and the numbers and the words and all of that. And so I just forgot to change the answer choices from the other problems. So the answer is the same. I was like, oh no, I hope that this doesn't turn out bad. The answer is the same. It just shows that you can use your understanding of unit rates and conversions, or you can use proportions, whichever one that you want. Two different mentalities gets you to the same place. All right, let's move on to problem number 3. Two numbers, P and Q, are shown below. P equals 9 plus 10 cubed times 4 plus 5 times 10 squared. And Q equals 7 plus 10 to the 6th power times 3 plus 7 times 10 to the 5th plus 1. When Q minus P is calculated, what digit will be in the thousands place of the difference? So we've got a couple of different steps that we can see. So they ask us to calculate Q minus P, and then they ask us what digit is in the thousands place of the difference. But in order to do that, we have to figure out what P actually is and what Q actually is before we can actually solve, right? And so in order to do that, I need to use order of operations to figure out what P's value is and what Q's value is. So I have P equals 9 plus 10 cubed times 4 plus 5 times 10 squared. And then I have Q is 7 plus, and my iPad just connected. That is common practice. My iPad just likes to randomly disconnect. And so that's fun. You know, it is what it is. So we're just going to reconnect it and we will continue right on with our math journey. So I'm going to use my order of operations to figure out how to do my difference, right? So I have to do Q minus P, but I can't do Q minus P until I actually have a value for those. So Q equals 7 plus 10 to the 6th times 3 plus 7 times 10 to the 5th plus 1. Okay, so order of operations, PEMDAS, keeping in mind that addition and subtraction are kind of together and multiplication and division are kind of together. And so I'm going to do multiplication and division in whatever order they appear in the problem. But I'm going to do those exponents first. I'm going to evaluate those exponents first. So I'm going to do 9 plus. Now, there's two different mentalities to this. You can do 10 to the 3rd times 4, or you can use your understanding of scientific notation to evaluate that. So 4 times 10 to the 3rd is the same thing as 10 to the 3rd times 4 because of the commutative property. And if you're not familiar, elementary people, if you're not familiar with what the commutative property is, you should be. And so everybody should really understand, like, this is really a K-12 problem because everybody needs to know order of operations unless you're like K3 or preschool. But 10 to the third times 4 and 4 times 10 to the third are the same thing. And so if I understand scientific notation, then I know that I can just take this 4 and hop the decimal 3 places and it becomes 4,000. I don't have to do the exponent first because I'm evaluating it at the same time. So I have 9 plus 4,000, but if you want to do 10 to the third, which is 1,000, and then do the times the 4, that's totally fine. Plus 5 times 10 to the second, hop that decimal 2 places, equals 500. So this equals 4,509. And I'm going to use that same understanding with Q. So I'm going to do Q equals 7 plus 3, hop it 6 times, 1, 2, 3, 4, 5, 6, plus 7, hop it 5 times, 1, 2, 3, 4, 5, plus 1. So that's going to equal 3, 7, 1, 2, 3, 7 plus 1 is 8. 370,008. So now what I need to do is, now that I've figured out what P is, which is this value, and what Q is, which is this value, now I need to do Q minus P. So Q minus P is 370,008 minus 4,509. Now, if you have a calculator, beautiful. That makes your life that much easier because you can just plug this into the calculator and you can get 370,008 minus 4,509, and that equals 365,499. And it asks us what digit is in the thousands place. And the thousands place is right here. 1, 10, 100, 1,000, 10,000, 100,000. What comes next? Million, if there was a million. And so our answer for this one would be 5. This is a very, very, very classic problem for a test, like a math certification test, because it does involve multiple layers of understanding, and they love to add multiple layers of understanding. And so this is definitely a very common type of problem. Sorry. All right, let's move on to problem number 4. Sam is trying to simplify the following expression. Sam is trying to simplify the following expression. Sarah, 5x plus 3y plus 2x. The first thing Sarah did was the following: 5x plus 2x plus 3y. What property did Sarah use to complete step 1? Associative property, commutative property, distributive property, or additive property? All right, so if Sarah is trying to simplify this, and we're trying to figure out what property she used to go from the first one to the second one, I'm going to rewrite these so we can see it a little clearer. Okay, and so what is the difference from A to B? What is the difference from A to B? Yeah, the order of these two items. So it's 5x plus 3y plus 2x, or it's 5x plus 2x plus 3y. And so what property is that a part of? Is that associative property, commutative property, distributive property? Which one is it? That is absolutely the commutative property. The commutative property states that we can add items in any order, and it doesn't change the value of the expression. So I can do 5x plus 3y plus 2x. I could do 2x plus 5x plus 3y. I can do 3y plus 5x plus 2x, and we're always going to get the same answer. The tricky part here that I want you to pay attention to in this one is that a lot of times we think of commutative property with 2 items or 4 items. And a lot of times associative property is represented with 3 terms or 3 items. So what I don't want you to do is get confused that this is the associative property because you see 3 items. What would make this the associative property is this. This would be the associative property. If we went from A to B, if we did 5x plus 3y plus 2x, and then we did 5x plus 3y plus 2x, the associative property says that if I'm doing all addition and I have parentheses around one set, I can change the parentheses from one set to another set and add those items first and still get the same response, which is why you often see associative property represented with 3 items instead of 2, because if you just had 2, you can't do the associative property. And so I think what they were trying to do was trick you into thinking that this is the associative property because there's 3 items that are being added in a different order. But if the order actually changes, then we're looking at the commutative property. Does that make sense? All right, let's go on to problem number 5. 2 coordinate points of a square include 4, 2 and 8, -2. What is the area of this square? What is the area of this square? All right, so everybody needs to understand how to do basic coordinate graphing, which means everybody really could solve this problem. This really takes coordinate graphing to the next level because what it's doing is it's mixing our understanding of like area and perimeter and volume part of geometry and the coordinate grid. So if we draw this out, that was a crooked line and I don't like that. If we draw this out, and that really wasn't that much better. And I plot these points, 4, 2. Remember, and I'm going to do a little like review on coordinate points. Remember that if I'm plotting this point, this is an x, y point, an x, y point. So if I'm going to plot an x, y, I'm going to make sure that I'm going horizontal first and then vertical. So I'm going to go over 4, 1, 2, 3, 4, and up 2, 1, 2. And then I'm going to go over 8, 1, 2, 3, 4, 5, 6, 7, 8, and I'm going to go down 2, 1, 2. And so you're looking at this and you're going, Amy, that definitely doesn't create a square. You're right, it doesn't. But I'm not connecting the dots per se like I would if I was drawing a line, right? I'm trying to figure out how this would create a square. So if I drew a square up here and I have a diagonal, which is really what I created on my graph, right? What am I missing? I'm missing these 2 points right here. I already have this point and this point. I'm missing the purple dots. Well, if it's a square, let's talk about things we know about a square. We know squares have the same length of sides, number 1. We know that they have 90-degree angles. And so if the green dots are 2 of our points and I'm creating a 90-degree angle, then I need to find the horizontal and the vertical lines that are going to create this square. So if I'm going to draw this square out, I know my other dot in the top right corner is going to lie on the same horizontal line as this green dot does. And I know it's going to land on the same vertical line as this green dot. So it is going to be right here, which is, if this is 4, 2, and this is 8, negative 2, then this is going to be 8, positive 2, because I'm going to go over 8 and I'm going to go up 2. Which means that this dot down here is going to be 4, negative 2, because I'm going to go over 4 and I'm going to go down negative 2. Does that make sense? So now that I have my graph, I want to know what the area of this square is. I know a square has equal sides, and so I just need to figure out what is the length of this side. Well, if I'm going from here to here, that's 1, 2, 3, 4. And if that's 4, then I know that this is 4. I don't need to count it again unless I'm not sure about this one. If I want to check myself, I can. 1, 2, 3, 4, right? And the area of a square is length times width, which is 4 times 4, which is 16. So my answer is C. Questions about that? Comments, concerns? Let's go ahead and move on to the next problem. Ooh, okay. This is taking that idea of the coordinate square to the next level. So one coordinate point of a square includes 4, 2. Another point lies on the line y equals 8. If the area of the square is 36 units squared, what could another point of the square be? What could another point of the square be? So let's take our coordinate grid again. So 4, 2 is one of the points of our square. And another point lies on the line y equals 8. Now, don't mistake y equals 8 for this line right here. That is the number one mistake people are going to make on this problem. They're going to say that y equals 8 is right here, and that is actually x equals 8. And I know it doesn't make sense because the y-axis is vertical, so you automatically think that a y equals line is going to be vertical. But if we think about the concept of what y equals 8 is, y equals 8 means I'm going up 8 every single time. So if I'm going up 8, then it's going to be a horizontal line that connects all of those vertical movements, right? So y equals 8 is where another point on the square lies. Well, again, if we're creating these 90-degree angles, another point on the square could be this one right here. Well, let's see if that's even an option. That point right there is going to be over 4 because that's how much we went over for the green dot. Up 8 because it's sitting on y equals 8. Is that an option? No, but that doesn't mean that you're on the wrong track. A square has 4 points. So just because that point is not one of the answer choices, it could be one of the other 3 points. What we have to do now is figure out what is this distance so that we can figure out what is this distance. Well, they told us that the area of the square is 36 units. Well, what times what equals 36 so that they are the same? Yes, 9 times 4 is 36, but that wouldn't be a square, that would be a rectangle. So 6 times 6 is 36, which means that this side has to be 6 and this side has to be 6. So now I have to count 6 units over from here. 1, 2, 3, 4, 5, 6. right there, right there. There's my rectangle. So what are those other points? Well, what is 4 plus 6? 10, right? So 10 comma something, 10 comma something. And then this is our original point, 4 comma 2. So we have 10 comma 2 or 10 comma 8. There's the other point of our square. Pretty cool, huh? All right, let's go on to problem number 6. A teacher is creating a quiz worth 60 points. The quiz will consist of questions worth 1 point and questions worth 4 points. Which equation represents this situation, where x represents the number of 1 point questions and y represents the number of, that should say 4 point questions? Which of the equations represents the situation where x represents the number of 1 point questions and y represents the number of 4 point questions? So if we're creating a quiz worth 60 points, we know that our equation is going to equal 60, right? And I know that x is the number of 1 point questions and y is the number of 4 point questions. So if I need to get to 60 points, I need to multiply the x times the value of the points that it equals, which is 1. And I need to add that to y times the value of the points that y is being, that the y questions have, which is 4. So 1x plus 4y or 4y plus 1x equals 60. So x plus 4y equals 60 is our answer. Now, what I don't want you to do is get wrapped up in the idea that I can add the 1 plus 4 and get 5. Because then if I multiply the 5 times x times y, that's not going to give me an accurate depiction of how many points my quiz is. So let's take a table, for example. If I have, 10 1-point questions, that's going to equal a total of 10 points on the quiz, right? Which leaves 50 points left over for 4-point questions. And 50 is not divisible by 4, so I know that that would not be the correct answer. So what I want you to recognize in this situation is we're not going to mix our x's and our y's or our 1 point and our 4-point values, because what that's going to do is it's going to add apples and oranges, and that's not what you want to do. You want to make sure that you are multiplying the correct thing by the correct variable that matches so that we can get an accurate equation out of it. Does that make sense? All right, let's move on to problem number 7. The graph of y equals f of x is shown, where the function f is defined by f of x equals ax cubed plus bx squared plus cx plus d, and a, b, c, and d are all constants. For how many values does x equal 0? For how many values does x equal 0? All right, so this is a whole lot of words for not really that difficult of a problem. So we have y equals f of x is shown. And they want to know, and then they say blah, 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 blah. None of that really matters because they gave us the graph. So all this is saying is that this is a cubic function with some numbers that affect it. That's all that says. And then they want to know how many values does x equal 0? And I'm telling you right now, the number one answer that people are going to answer is 3. Because so often we are asked for how many values does f of x equal 0, which would be y equals 0. We are asked that so often. We're asked so often, how many zeros are there? How many times does the graph cross the x-axis? How many times does y equal 0? How many times does the function equal 0? But we are not asked very often, how many times does x equal 0? And so a lot of people on this problem are going to choose 3 because they're going to immediately see that this graph crosses the x-axis 3 times. But every single one of those has an x value. Like this is, oops, that's not what I was looking for. This is the coordinate point 4, 0. This is the coordinate point 7, 0. This is the coordinate point -1, 0. All of those dots have an actual x value. How many times does x equal 0? Where does x equal 0? The y-axis. And the y-axis is right here. How many times does this graph cross the y-axis? Only 1. How many times how many values does x equal 0? Only 1. That was a trick question. All right, let's move on to problem number 8. A farm consists of 2 separate areas, a 4-hectare living area and a 38-hectare farming animal area. The total number of trees on the farm is 4,832. And the equation 4x plus 38y equals 4,832 represents the situation. Which of the following is the best interpretation of x in this context? A, the average number of trees per hectare in the living area. B, the average number of trees per hectare in the farming animal area. C, the total number of trees in the living area. Or D, the total number of trees in the farming animal area. All right, so this is an interesting question because it has some vocabulary that you may not know. In fact, when I built this question, I didn't know what a hectare was. And so it's an interesting little problem because there are problems on these tests that are going to have vocabulary you don't know. And they do that on purpose because they want to see how you're going to read the math problem and apply it. And so a 4-hectare living area, it really doesn't matter that you don't know what a hectare is. It's some measurement of land for this farm. And the 38-hectare is some measurement of land for that area. And so they tell us that the total number of trees is 4,832. So our equation equals 4,832, which, yeah, we know, we get it. But then they have 4 times x plus 38 times y. And so what does x equal? Well, x is going to be, if this whole equation equals 4,832, which is the number of trees, then x and y have to be some amount of trees, right? And I'm multiplying it times the 4 hectares. I'm multiplying this y times the number of hectares. And so is it going to be an average number of trees or is it going to be a total? What I do know and what I can eliminate right off the bat is this right here. I can get rid of anything that talks about farming and animals because the x is tied to the 4, which is your living area. If the x is tied to the living area, then it's not going to be the farming animal area, right? And so I know it is either going to be the average number of trees per hectare or it's going to be the total number of trees in the living area. Well, the total number of trees in the living area is going to be the number of trees times the number of acres, right? So it's going to be the average number of trees per hectare. Now, that's a weird one because normally when we're dealing with this kind of problem, we're not dealing with an average. But you have to apply what you know to the context of the problem. And so in this situation, and this is actually, I'm going to be honest with you, when I saw the problem that was similar to this is the first time I've seen a linear equation written with an average number applied to it. But the more that I thought about it, the more it made sense. It can't be the total number of trees in the living area because that would be what this entire unit is. This unit is the total trees. This unit is the total trees in the farm, and that equals total trees. So it can't be total trees. Does that make sense? So almost through process of elimination did I get to the correct answer. All right. So we have gone through quite a few problems. Let's go ahead and do one more. Let's go ahead and do one more problem, and then we'll wrap up for the night. The function defined as f of x is shown below. What type of roots does the function f of x have? What type of roots does the function f of x have? 2 rational real roots, 2 imaginary roots, 1 rational real root, or 2 irrational real roots. So for my middle school and high school people, even my Praxis, core, GK people, you need to understand basics of quadratics. So I can have a quadratic equation that does this. I can have a quadratic equation that does this. Or I can have a quadratic equation that does this. Or they can do all of those things upside down. So in these situations, this is going to produce 2 roots. This is going to produce 1 real root. And this is going to produce no real roots. It does not mean that I can't find the roots. It just means that I have no real roots. So this is 2 real, this is 1 real, and this is no real. And we just disconnected again. Let's go ahead and reconnect and we'll finish this problem for tonight. All right. With that said, you'll notice the answer choices have 2 rational real roots and 2 irrational real roots. All that does is a rational real root is one that has a clean answer, like 2.5 or 4 or 7. An irrational root is something that's like 2.13573, blah, 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 blah. Like a decimal that is just infinite, right? An imaginary root is going to be something like this. This is going to produce 2 imaginary roots. If it bounces, it's just going to be 1 real root, and it could be rational or irrational. And if it goes through the axis twice, it's going to be 2 real roots. Whether they're rational or irrational is a whole nother conversation. And that can be found using the discriminant, but we're not doing discriminant today. We can do discriminant another day. But that is how you figure out how many roots that function has. All right. Let's go ahead and close out for tonight. Let me know, as always, if you have any questions in the comment box. Find me on social media. Let me know. I'm happy to include them in the upcoming weeks. And I look forward to seeing you next week for our next episode of Wednesday Night Math Night. I'm going to turn it over to Dr. A, and I will see you all next week.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions that I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.